Hey people! You guys want to become experts on redox reactions, huh? Then you've come to the right place. Alright, let's get started. Okay, so of course you're familiar with oxidation and reduction and all that stuff, right? And I bet you can determine oxidation states in your sleep by now, huh? Well, what's a redox reaction then, and what does it have to do with electrons? It's really simple actually. A redox reaction is a reaction that involves both oxidation and reduction, and the two processes just happen simultaneously. Oxidation refers only to reactions where electrons are lost, and reduction refers to reactions where electrons are gained. So what does one of these redox reactions actually look like? Well, let's go ahead and take a look at an example of one. Okay, so what we're looking at right here is the reaction between chlorine gas and elemental magnesium. When these two tough guys come into contact, this is how it goes down. Now, as you know, redox reactions have reduction and oxidation processes going on at the same time. This whole thing looks a lot neater though if we look at the two reactions separately. So first, let's see what's going on with the magnesium here. Before the reaction, we've got this neutral magnesium atom, but afterwards, it's going to have a charge of +2. For ions consisting of a single atom, the charge of the ion is the same as the oxidation state of the atom. This means that the oxidation state of the magnesium in this reaction jumps from 0 to +2. And since the oxidation state increases, we know that the process we're looking at is the oxidation part, because oxidation means electrons are being lost, remember? Alright then, so we can describe this oxidation process by saying magnesium turns into magnesium 2+ by giving up 2 electrons. Alright, now let's do the same for the chlorine gas. The chlorine gas on the left is neutral, but on the right, it has a charge of -1. Here too, the oxidation state corresponds to the charge. And since this one's going from 0 to -1, we know that this process has got to be a reduction. In the reduction process, the chlorine actually picks up the electrons lost in the oxidation process, so we write in those electrons in front of the arrow. But wait, how did we get an oxidation state of -1? Well, we have 2 chlorine atoms here, and each one picks up 1 electron, which means each individual chlorine atom gets an oxidation state of -1. Great, moving right along. In the next step, we're going to go ahead and combine the two equations, since they're actually happening at the same time anyway. So with the complete left side looking like this, here's what the complete right side of our equation is going to look like. Put them together and our redox reaction is almost done. Alright, now here's the last step. We need to check and make sure we have the same number of electrons on each side. Look at our example here, and we can see that there are 2 electrons on the left and 2 on the right as well. Sweet! Now we can say that we're done here for real. For the sake of clarity, we can also just leave out the 2 electrons on either side of the equation. Okay, that was a pretty easy redox reaction to start with, because if the electrons don't add up to the same number on each side, then you've got to rebalance the equation. But let's leave that for another video. Okay, so let's sum all this up. A redox reaction always involves the reduction process and oxidation process happening at the same time. If we want to understand what's happening and how, we first need to see what the oxidation state of each of the molecules is. That will show us whether the oxidation state is increasing or decreasing for each individual atom or molecule, so we can see where the oxidation is taking place and where the reduction is taking place. We write out the oxidation process and the reduction process separately and add electrons to either side as needed. If the same number of electrons are involved in each process, we're done and it's party time. But if the two reactions don't have the same number of electrons, then we're gonna have to go ahead and balance it out. If you want to know how that works too, come on and check out our video on it. See you there!